me. Yeah. All right, so before we get started, I got a song.
Just hit a button, Morty. Give me a beat. Oh man, okay, all right. Oh yeah, you gotta get swifty. You gotta get swifty in here. It's time to get swifty. Oh, you gotta get swifty. Oh yeah. Take off your.
Okay. Okay, so real quick before we get started, please save all your questions until the end. We should have enough time to answer any questions you may have. Write them down, save them. As far as requirements go, this is not a beginner's course. So if you don't have coding experience, you're probably going to have some difficulty understanding some things. You should have a MacBook, but it's not required. If you do, please install Xcode if you haven't already. But it's going to take a while to install because it's big. So just do it now and you can worry about it later. Optionally, you will want to have an iPhone or an iPad so we can build our app and deploy to these devices. Okay. But for the most part, I'm not doing any like real live coding. You're not going to be following along. This is just informational. So just listen up, write down your questions, and I got a lot to tell you. Okay. All right. So I'm Brian, founder of Titanium Inc., company I built last year. We build all kinds of software. I am also a JavaScript teacher for LeWagon and a mentor. I'm a maintainer and contributor for the Swift Mav SDK, which is some open source software for the PixHawk flight controller that are used on drones, industrial drones. And that means I'm also a drone pilot. I do 3D printing, father, husband, and mentor. You can scan my QR code, add me, ask me questions. Just don't bug me too much. I am providing a file in the CoHack group with this keynote or these slides in PDF format. It does have clickable links. There's also a book in there. There's a guide, and then there's the project files and assets and stuff that you'll need to build the project we're going to build today. Okay. All right, so these are some apps that I've built previously. Lucky English, some of you know, I built for my daughter. It is published and on the App Store. It took me about a week to build, and that is to design from scratch and then build and deploy to the App Store.
My daughter loves it.
Yeah. I actually got something cool to show you guys later, too. I didn't know about until I started doing this. I also built an app called Rip-A-Trip, which is no longer on the App Store because the founder decided to go an alternative direction and build a website. And then I was working with someone here in Chengdu building a game or an app called People Game, but that didn't work out. But I also have built tons of other apps, and you'll have a quick preview of those later. So what are we going over? I'm going to go over the differences between native and cross-platform. We're going to talk about a little bit about benchmarking, future-proofing, and accessibility. Then I'm going to go over some basics with Swift. Again, I'm not going to go deep into it. You should know how to program, so if I tell you what a variable is, I shouldn't have to explain how to create one. And then we'll do the Xcode in a nutshell. I'll give you a tour around Xcode. I'm going to build an app for you, and I'm going to show you how to deploy it to the App Store. So by the time you guys walk out of here, you should have some sort of an idea how to start putting apps on the App Store. All right. What is Swift used for? A lot of people think, okay, it's only for Apple devices. Kind of. You can use them on Apple TV, iMacs, laptops, watches, the phones, iPads, even CarPlay. You can also use it on Ubuntu, and Google, for their machine learning software TensorFlow, they're using that as well for Swift. You can also use it server-side. So if you want to build APIs or websites, you can use Katura or Vapor to build your Swift backend. And as far as coding in Swift, you can use VS Code or Sublime, or you can use the provided Xcode or Swift Playgrounds. So what is Swift Playgrounds? If you have an iPad, you can download Swift Playgrounds and it teaches you how to code in Swift. It's actually built more towards the children and teenagers, but as adults, you can most definitely use it. You are given tons of example apps in like different playgrounds that you can download and work through. Basically, it just runs you through on how to code, and then you need to move the little guy around to collect the gems. Or if you just want to test Swift out and write some sample code while you're on the metro or on the bus, you can do so right from your iPad, okay? If you do not have a MacBook or you do not have an iPad, you can go to online.swiftplayground.run and you can practice Swift in that. I will provide a link later for Windows users to install a development environment to work with Swift. However, that being said, if you want to deploy apps to the Apple Store, you have to have a MacBook, okay? Virtual machines and things like that are going to be very complicated. Yes, Apple traps you by doing that. This is why I'm a fanboy. All right. That being said, if you join the Apple ecosystem, they provide you with lots of things. As you can see here, we have frameworks, we have services, tools, and all kinds of things for games and graphics. They even tell you how to build accessories for their devices, such as wristbands, okay? They provide you with a lot of information and different tools and stuff like that. That's all accessible through the apple.com website. So if you want to learn how to use MapKit or HomeKit or any of these kits, you can do so. Now, if we go and click on this link at the bottom, developer documentation, this is going to take us to developer.apple.com. And here they document all of their frameworks and how to use them. It's very extensive, okay? And it covers everything. So if you need to find anything regarding Apple and Swift, you can find it here. They also provide you videos for all the WWDC events in the past years, which you can watch here. So if you want to learn about the new Swift UI information, you can do so by watching a few videos, or you can go down to the bottom and view the complete collection of videos that Apple has recorded for you. So lots of information provided to you, all in one spot, and there's no like third-party libraries or anything like that. It's all Apple, okay? It's all supported by Apple. All right, so let's get into cross-platform and native and the differences. All right, so what are the pros of cross-platform? A lot of people say, you know, I'd rather use a cross-platform because cost effectiveness, you know, easy code sharing between different versions of apps. We have faster development, you know, portable across multiple platforms. And then, of course, time-saving, budget-friendly, things like that, right? But the cons of cross-platform come into the integration of the Apple platform, okay, or the Apple ecosystem. Also, poor user experience because a lot of them don't use style guides, which I'll talk about in a little bit. You also have lack of graphics and 3D supports. You can't use ARKit or MLKit, okay? There's a lot of hardware-level things that you don't have access to with cross-platform. You also are dealing with slower performance and efficiency, and you'll have difficulties dealing with errors that are on a hardware level, okay, that cross-platform isn't built to handle. And then, of course, it's new. Okay, Apple has invested a lot of money and a lot of effort into their systems, and they're fixing bugs constantly, whereas with a lot of the cross-platform systems, it's either open source or built by third-party libraries, etc. That being said, what are the pros and cons of native? Pros of native, we have easy deployment because everything you are building is built for that system, so it's a lot easier for deployment-wise. Efficiency, performance, and then, of course, easier UI because the native apps follow style guides, which, again, I will talk about in a minute. They're more safe and secure, and you just have an overall high-quality app. But as far as the cons go, it's expensive. Okay, if you want to develop for Apple and you want it to develop for Android natively, you generally have to hire 2 developers and 2 designers. Okay, and the source code is unique to that platform, so sharing it amongst other platforms is difficult. And of course, you have higher maintenance costs, and then it's of course time consuming. All right. Airbnb and Dropbox actually just released this like 2 days ago. They used cross-platform. They used React Native, and they wrote articles about their experiences. I've provided you the links to these articles. I recommend you read them thoroughly and understand the differences between cross-platform and native based on their experiences. However, that being said, I'll give you a quick overview. This graph shows you when cross-platform can come into use. When you are typically building demos, MVPs, or single-use apps, such as like apps for conventions or things like that, you'll want to build cross-platform because you can get them out quick, right? You don't need to hire a huge dev team, and you're more than likely to just throw it away in the end and not build onto it. But if you decide to build a very complex app, that's when things become a problem. You're going to end up reinventing the wheel with a lot of modules and frameworks and things like that that have already been built on the native side, but haven't been built on your cross-platform side, okay? And that, again, is explained in those articles through Airbnb and Dropbox. They ended up having to rebuild things entirely and deal with bug issues that were caused because of cross-platform. All right, so let's talk about accessibility. Now, I mentioned style guides. Human Interface Guideline and Material.io are style guides provided by Apple and Google. Apple is the HIG, and then Google is Material.io. They build specific guidelines on how you should build your apps, how they should perform, function, be used, etc. And the reason they do this is because they want to give the user the same overall experience between all of their apps. So when a user downloads your app, they're not searching for the back button. They're not trying to figure out how to get to their profile or to turn off some settings or anything like that, how to add content. Like all of these things should be common across platforms or across apps. That way, they're familiar with this experience. And that's why these guidelines are built. The problem with cross-platform is they don't take into consideration the variations of these guidelines. For example, Apple's navigation on apps is at the top, okay? Whereas with Android, it's at the bottom. You have your hardware level navigation, your back, your home, and your options, right? The back arrow, the dot, and then the square. So if you're not taking that into consideration, you're gonna run into a lot of UI problems as far as design-wise. And if you're building one app for all platforms, you're not thinking about that, okay? Another thing too is if you don't follow Apple's guidelines, they will deny you and you will not be publishing your app on their store. So the other thing to discuss is native API accessibility. Like I was telling you, you do not have access to a lot of API functions provided by Apple or Android. I'll give you an example. I was building a cross-platform app that required me to use high precision GPS. The problem that I ran into is that the cross-platform system that I was using only gave me one switch to turn on high precision. Whereas with the native platforms, I had 8 different options per platform to turn on high precision. And that resulted in me having, for the cross-platform, a precision of 10 to 20 meters versus the native side of like 1 to 5 meters, which is huge if your entire app revolves around that, the calculation of a specific location. And then you need to consider too that, JavaScript can't be used for low-level development. It's a scripting language. Another example, it's doing calculations on GPS locations, and JavaScript was cutting off my zeros, which threw off my numbers. And I had to use third-party libraries and things like that just to get it to work. JavaScript is single-threaded. It's not multi-threaded. It's a simulated multi-threaded, okay? And you don't have traditional OOP features available to you using cross-platforms. Now, they do claim native. I don't know how true that is, okay? Especially when you're using a scripting language. All right, so benchmarking. How fast are they? ResearchGate did research on this. I've provided a link in the blue text here. They did a test with Xamarin and the native platforms. So hands down, Android performed best on 3 operations: calculation, save file, and localization. Okay, Xamarin did better on some of the others. Whereas with iOS, it beat it across the board. Okay, and again, when it comes down to building those simple apps that you just will take a week or 2 to build, these calculations don't really matter. But when you get into the very complex apps and 10 to 20 second calculation time is happening, then those things matter, right? All right, so let's discuss a misconception between building native and cross-platform. So a lot of times I hear, well, if you build native, then it's difficult to take the code from one platform and bring it over to the other, right? That being said, there is a website provided called Swift is Like Kotlin. It actually breaks down all of the language basics and things like that, and some functionality between Swift and Kotlin. And you'll see through this website that they're actually very similar. So much so, like, creating a variable is exactly the same. The differences come into like what frameworks and APIs are being named as and how you're using them, and that's just platform specific. And so if you really are concerned about having to rewrite your app, it's actually not that difficult to do. Okay. All right, let's get into the basics. So I played that song in the beginning. Being Swifty. What is Swifty? Well, being Swifty is writing human-readable code, okay? So a quote: if someone needs to see the implementation to understand what a method does, you have failed at being Swifty. What that means is, if I have to look at a function and I have to read through the entire function and look at, what is called it, and then look at the output, run some tests, read your comments, you failed at being Swifty. I should just be able to look at your function name and the parameters and know exactly what that function does. Okay, I shouldn't have to dig through your code. That's the beauty of Swift, is they've developed in a way that it's easier to write and it's easier to read. Okay, Swift.org provides this. Writing Swift code is interactive and fun. The syntax is concise yet expressive. And Swift includes modern features developers love. Swift code is safe by design, yet also produces software that runs lightning fast. And I'm going to talk a lot about how safe Swift is. All right, so if you want to follow along and kind of type out these examples, it's great. You can go to that website that I provided earlier, or you can open up Xcode and click on Get Started with the Playground. Okay, so there is Swift Playgrounds on the iPad, and you have Playgrounds as well through Xcode. So this is the basic syntax for Swift. It looks pretty similar, right, to everything else. It's not scary looking. You have your comments, create a variable. We use double quotes for strings, and then we use parentheses to call a method. So Swift offers the programmer a rich assortment of built-in as well as user-defined data types. The following types are the most frequently used when declaring variables. We have our signed and unsigned int 32 and 64-bit. We have floats, doubles, booleans, strings, characters, optionals, and tuples. We also have type alias, which is a type we can define ourselves. Okay? And this goes into how safe Swift is. So if you define a type and you try to assign a variable with a different data type, you're going to error out. It's not going to allow you to do that. Okay? If you don't assign a data type to a variable or a constant, it will automatically infer that type based on that data that you've given it, and it will remain safe thus forward. Okay? So each variable in Swift has a specific type, which determines the size and layout of the variable's memory, the range of values that can be stored within the memory, and the set of operations that can apply to that variable. So this is why it's very safe, is because if you define something as a specific type, you're only allocating so much memory for that variable. Okay, which this is why like Swift is so fast, is they just manage all of this for you. Creating a variable is with the keyword var. We can do type annotations with our colon and then our data type. And if we want to create constant, it's the same. Constants we use the keyword let. Again, we can do type annotation on our constants. All right, so optionals. Who heard optional for the first time tonight? Right? Okay. So optional types. These are handled as absence of values. Okay. They say if there is a value, then it equals X, and if there isn't a value at all, it's nothing. Okay. An optional is a type on its own, and it has two possible values of none in some parentheses T, where T is an associated value of the correct data type. Now, I'll explain optionals a little bit more, but how to declare optionals is you create your variable, you give it a name, you define its type, and you put a question mark at the end, and this declares an optional. Okay? What this is saying to the compiler is that this should contain something, but I don't know if it does. Okay? And it delivers it to you in a package. Think of it as a gift-wrapped package. To get to the data inside that optional, you have to unwrap it. And we have three ways of doing that. We have automatic unwrapping and forced unwrapping. So automatic unwrapping is as soon as you declare it, it's automatically unwrapped. It's opened for you and it's presented for you. But that's not safe, because there could be a chance that there's nothing in there, which will crash your system. Then there's also forced unwrapping. When you're using the package, you automatically open it and then you use it. But again, we don't recommend doing automatic unwrapping or forced unwrapping because it's not safe. You don't know if the value is actually there. Okay? So if you're getting data from an API and they haven't provided you that information and you go to unwrap it, your system crashes. And that's what Swift tries to avoid, is crashing your system. Okay? Bad user experience. So what we recommend is called optional binding. This is taking the value of that optional after we unwrap it and assign it to another variable to which we use. If it unwraps and there is data inside that variable, then we can proceed forward by using that new variable. Otherwise, we will present ourselves with an error or the else statement. Okay, and that's basically optionals in a nutshell. There's more advanced features of optionals, but this gives you a quick overview. We also have optional chaining, which is basically if you have an optional inside a class and you've use class inheritance or something. The premise of this is if one optional fails, the whole thing fails. Okay, so this is where you're checking your optional types inside your code and making sure everything unwraps properly. And if it doesn't, it gives you a nil back for the whole thing. And then tuples. So tuple types, which are used to group multiple values in a single compound value. The values in a tuple can be of any type and do not need to be of the same type. So you can pretty much put anything you want in a tuple. Okay? And you can actually give it a key as well. So for example, the var error 501, we have error code and description as the keys, and then we can get our values back for that when we call it. And again, they don't have to be of the same type. We have our basic decision making of if, and else statements. The only difference between this and a lot of other languages is we don't use parentheses in our conditional code. We have our switch statements. We use switch and case, and our default keyword is default, to which you have to have. If you don't have default, it'll crash, okay? And we have loops. So we have a for in loop, and we have a while loop. While loop is the typical while loop that you would use elsewhere. You have to have an external index. And then the for in loop is unique to Swift in the sense that we can increment through an array, but if I don't want to increment through the entire array, I can increment through, let's say, 10 by doing ... 10. Or if I want to increment through part of an array, let's say from 3 to 10, I can say 3 ... 10. And there's actually a lot more options available to you as far as for in loops. I recommend reading up on that. We also have loop control statements, continue and break to stop the loop if we need. Do some external checking or anything like that. Creating strings, it's the same as any other language, yeah? Double quotes, we can do a string instance by calling string and then the string method, or we can do multi-line string with our triple quotes, okay? It's not scary, is it? It looks pretty similar to everything else. So characters. Who heard character for the first time as a data type tonight? You ever used characters before in any of your languages? C#? Yeah? Okay. So then let me ask you this. Why is there a character data type in these lower level languages? Huh? So they're used as single character string literals, and it's used for like localization. So when you want to localize an app or something like that, then you will assign you will have a character type. And actually strings are arrays of characters. So you can get into a string by accessing it like an array. Okay, so everything's built off of the original character data type. So the Chinese character for ni is actually a categorized data in Swift. Okay, and it's primarily used for localization. All right, creating arrays, same thing. When we're creating arrays, we do our square brackets, define our data type, and then we can initialize it without values with the parentheses. Or you can look at the second line and we create an array, give our data type, and then give it values with our square brackets. Okay. Swift puts strict checking, which does not allow you to enter the wrong data by mistake. So all the data needs to be of the same type. Okay. And if you try to input anything else in there that's not of the same data type, it'll crash on you. So sets. Sets are used to store distinct values of the same type, but they don't have to be in order. And you can use sets instead of arrays in ordering of elements is not an issue, or if you want to ensure there are no duplicates. Okay, so if you try to put values into a set that are of the same data, then it will just remove it for you. Okay, so if you want to get rid of duplicates and stuff like that, you can use sets. And there's lots of methods you can use on sets as well. We have dictionaries. Dictionaries are used to store unordered lists of values of the same type. And Swift also puts strict checking on dictionaries. So you cannot put the wrong data inside a dictionary if it's already defined by its type. You can see now how strict Swift is with its types, right? It's not going to let you mess up whatsoever, unlike JavaScript, where you can make a string into a number really easily. And functions are defined with the keyword func. When it's newly created, it may take one or several parameters, and it processes the function in the main body and passes back the value of the function as an output return type. So to create a function in Swift, you'll notice, I'll break this down for you, that we have the arrow, right here. Here's my mouse. Okay. We have the arrow and then the data type of string. That's our return data type. So we cannot return an int or anything else. We have to return a string. But when it comes to the parameters, you'll notice that it's a little bit different from other languages and how they create functions. Swift gives us the option of creating an internal and external named parameter. So that means when we want to call a parameter from outside the function, we can give it an external name, and you'll see it's their name. But if we want to use that variable or that parameter inside the function, we can name it something else. This allows us to be extremely Swifty. Okay, this allows us to write out the names of our functions, and you'll see it as I'm writing this app later in a way that we can just read it real easily. That being said, if you don't want to give it two names, you can give it a single name by replacing their name with an underscore. And then when you call that method, you would call it using student's name rather than their name. Or you can completely remove both names, replace them with an underscore, and you don't have to call it at all. You can just say student and then string. Okay? All right. So closures in Swift are similar to that of self-contained functions. Constants and variables references define. Sorry. All right. We have three types of closures. We have a global function, which has a name and doesn't capture any values. We have nested functions, which has a name and captures values from enclosing functions. And then we have closures, which are unnamed and capture from adjacent blocks. Who can tell me what this is like in JavaScript?
Anonymous function.
Yes, it's just like an anonymous function, okay? So to create a closure, we create a variable equals square brackets. But inside our closures, we're also using our parentheses, passing it parameters, and then giving it a return type and using the keyword in to create a closure. And then later on, when we want to call the closure, we create a new variable and then pass it the method, okay? We can also do trailing closures. We have enumerations. So enumeration is a user-defined data type which consists of a set of related values. The keyword enum is used to define enumerations data types. So this is a structured enum. This allows us to structure our code so when we go to create a variable or something, we can actually structure it beforehand, and then when we go to use it, our compiler will check to make sure that it follows that protocol. So we're not creating some random things, okay? And then we have structures, okay? The structure is the variable values are copied and pasted into subsequent codes by returning a copy of the old values. So what this allows us to do is if we want to have a default set of values as, let's say, a type that we're going to reference later and we want to pull some equations on, then we can set up a structure so we can always go back to that without having to worry about it changing on us or anything like that. And that way we can assign these to a new variable and then do what we need to with it and move forward, okay? We have classes. Classes are created like any other language using the keyword class. Initializers and methods are also. So properties inside are also the same as any typical language. And methods, using the keyword func to create a method inside a class. And our inheritance, so class inheritance, we're just using it as a data type as well, okay, like we would with any other language. And then initialization, using the keyword init, okay. The other thing that we have is deinitialization. So before a class instance needs to be deallocated, deinitializer has to be called to deallocate the memory space. So we use the keyword deinit, and what this basically does is it deallocates the memory space occupied by the system resources, and then deletes it from memory in that instance. But so we have a thing I've talked about here is dealing with memory in your apps, right? And how safe Swift is, so you're not putting bad values in there and crashing your app or anything like that. And we have our structures with enums and structs and things like that that allow us to set up our classes or set up our data types so we can check everything as we're coding. And it allows us to just easily start typing and start writing our code without having to worry, checking on what something was. It all is done for us. So memory management functions and the usage and its uses are handled in Swift through automatic reference counting, or ARC. ARC is used to initialize and deinitialize the system resources, thereby releasing memory space used by the class instances when the instances are no longer needed. ARC keeps track of information between code instances and manages memory efficiently. And you can see here, there are lots of things that ARC does for you. Basically, it's going to initialize and deinitialize memory for you. And we also have something that ARC does is it creates strong references to properties, methods, and things like that from classes. But ARC, or the deinitialization, is only available to classes. So if you initialize a class, you create some properties and methods inside it, but you want to save those for a later time, you can reference those methods and properties as strong. That way, when ARC deinitializes your class, you can still access those methods and properties later, okay? And we have typecasting. I'm almost done with the basics, and then we'll get into Xcode and creating the app. I wasn't kidding, this is for advanced. All right, so we have typecasting. Basically, we have two keywords in typecasting in Swift. We use is and as. Is checks the type, and as casts the type, okay? And extensions. Extensions are my favorite. So if you want to extend the functionality of a class, structure, or enumeration, you can use an extension. Extensions can't be used to overwrite these things. You can only extend. So in this example, I want to extend the data type in, which allows me to create the methods add, sub, mul, and div, right? So anytime I have an integer, I can just use dot notation, call the method, and I can execute that method, okay? And that means you can write an extension for anything. So if you have frameworks or classes or anything provided by Apple or any third-party libraries, you can extend them to suit your needs. You have total control over that. Protocols are described methods. They're basically class properties. So they're structures for properties on how you're going to create a class, okay? And allows you to create that. And then we have access control. So access control, well, it gives you access to certain classes, properties, methods, instances, etc. We have public, internal, and private. Okay, no more code. So let's take a look at Xcode. And let's see how to build an app and deploy an app now that you know some of the basics of Swift and what you can do with it. And it is pretty advanced. There's a lot you can do, and there's a lot as far as frameworks and things like that that Apple provides you, okay? So you can do a lot with it. So, Xcode. You guys see this, right? All right. So this is my app, Lucky English, and this is Xcode. So Xcode provides you with a...
Ryan, I'm getting old. Can you make that bigger? Is that possible? I'm pushing 40 here, buddy.
I think I have to increase my resolution, so 1 second. No.
I just thought I'd ask. Don't let me
Okay.
let me don't close that.
Can you, like, put on your glasses?
Yeah.
All right, so you have your navigation panel, and you have your inspector, and then you have your debug area, okay? So over here is your navigation panel, and in here you have your project navigator, your source control navigator, symbols, find, issues, tests, debug, breakpoints, and reports. That's all presented in this navigator. Down here, you have your debug area that gives you all your debug information, and then you have your debug console. On the right is your attributes or your inspector for any attributes, sizes, things like that. These buttons up here are your standard editor, your assistant editor, and then your version editor if you want to check the differences between files. So in any app, you're going to be presented with this root file, and in here you'll have general, build settings, phases, rules, and things like that. This is where you name your app, give the version, give the build number. This is also where you do signing, because app makes you sign your apps through your developer account before you can put them to the App Store. This is also where you set your deployment information, such as what versions of iOS it can be deployed on, if it's available to iPhone or iPad, and then, of course, if you want landscape and hiding status bar, etc., and then a bunch of other information, okay? And then this little button here is your library. So if I go into my main.storyboard, and a storyboard is where you are designing the UI of the app, okay? This is where you can connect views, and these are all views, and then you can add elements through your library in here. And you can see I have a lot of different elements, or you can list them out as buttons in different views, AR views, sprite kit views, things like that, that allow you to go in and create, different interfaces, okay? And then inside, so if I click one of these elements, you're going to notice that my inspector on the right side is updated, because now I have access to my identity inspector, which allows me to assign a class to that specific element or view. And then I also have my attributes inspector. So for different elements in the app or the storyboard, you can modify them through here, such as font, colors, sizes, things. And then you also have your size inspector and your connections inspector. And this basically describes all of the connections that this element has. Okay, so if I click on the whole view for main menu, here you'll see that I have triggered connections, outlets, segues, things like that, okay? So there's a lot of complexity when it comes to developing these, as far as like what you can do and stuff. All right. So, and then as far as Xcode goes, up at the top, you have your source control for Git, your version controlling, you have your debug menu, and product menu is where you can run your app, where you can do profiling, and profiling is running tests on the interface itself, on the speed of functionality and things like that. You can test your memory usage and everything else within profiling. And then, of course, your archive is how you upload your app, okay? Editor, navigator, and all the other typical stuff. All right. Now, let's build an app. I'm going to build this app. And what this app does is when I click that little power button, a sound's going to be made, and the little rocket ship's going to shoot up, and then hustle mode is going to be presented. Really simple app. It's not going to take us long to build, okay? You'll see how it's done. All right. So the first thing I want to do is come into Xcode. And you can follow along if you want. I've already provided all the assets and the source code and everything else in the group. So if you just want to open the app and look around, you can. Okay. So what I'm going to do now is I'm going to open up Xcode, and I'm going to click on Create a New Xcode Project. Now you can see here that you have options for iOS, watchOS, tvOS, and macOS, and then of course cross-platform. Okay. And a lot of options with those. Well, we're going to choose a single view app, and I'm going to give it a name, and I'm going to call it Hustle Mode. Okay. The team is, if you have purchased a developer account, you will have this personal team here. Sorry for the resolution. Do I need to increase it? Okay. So the team, if you have a developer account, you will have your developer account team name here, and if it's for a personal usage, then it's just your name. Otherwise, you will most likely see this, personal team, and that's for your local account, okay? You have to have a team because you need to sign apps. Or if you're working with another company, then it'll be that team. Organization name is your company name, which can also be your personal name. The organization identifier is the reverse domain identifier. So my website for the company is titaniuminc.com. I'm just reversing that and doing com.titaniuminc. And you'll notice that the bundle identifier then becomes com.titaniuminc.hustlemode. This is used to identify your app. And if you name an app, like I have named Lucky English on the App Store, that is unique and it is yours. If anyone else ever tries to make that, they'll be denied. They have to go through an entire claims process with Apple to take that name back, okay? So no one can create duplicate apps, okay? Of course, choose the language Swift. If you want, you can do Objective-C. We're not going to be using core data, and we're not going to be doing tests or anything like that, so uncheck those, hit next. We're going to just save it to our downloads, hit create. And we're presented with this. Okay, so as you can see, we have our general tab, which gives us build settings and stuff, our name, version 1, build 1. My team's already selected. I want to choose deployment target iOS 10 because some people haven't upgraded their iPhones yet. And a tip, always choose iPhone first when you're developing an app, because if you submit something to the Apple Store and you say that it's also available on the iPad, Apple is going to check to see if it works on the iPad, and if it doesn't, they will deny you, and you can't go back. That means you're going to have to rebuild the app for the iPad. So just start with the iPhone and then later on upgrade to the iPad. And I want to get rid of landscapes because I don't want them to be able to turn the phone, and then I'm going to do hide status bar and require full screen. All right. Then we're going to go to app delegate, and this is the basic methods to start the app. If you're familiar with WeChat, they have this sort of thing too. It's just, standard methods that are ran to start any app. We have our view controller, which is the main class for the main view in our storyboard. And you'll see that we're also provided view controller. Now earlier I mentioned in the attribute inspector, if I go to the identity inspector, I can assign my class. And this is literally the class name that I've created. So viewController.swift, its class is assigned to this view in the storyboard. Okay? If I want to create a new view, I just come up to my library, I search for view, I come down to view controller, drag it, and then I do Command N, create a CoHack class, give it a name, click on that view, and assign it, okay? Then we have our assets folder, which contains all of our images and our app icon. And if you click on app icon, you'll see that it has various sizes. And this is set for iPad and the Apple Store and everything else that you need. Okay, and if it's for macOS or whatever, you would give these sizes. Okay, and it gives you 40 PT and then 2x and 3x. So what we're going to do is, in the provided assets that I gave you, I'm going to come here to all these images. I'm going to select them, unselect the WAV file because I'm going to put that somewhere else. And I'm going to drag this right into the, I'm going to drag this right into the assets folder. And you'll see that it creates a single list for all the images because I've had 3 for the 3 different sizes. 2x is used for iPads, and 3x is used for like Mac and the IT or the TV, Apple TV. Okay. And then you have your launch screen, which is a typical like logo or the screen you see when you open the app up. That's your launch screen. And your info.plist, which is basically like a configuration file. This is also where you go to. If you need to use the GPS, you have to explain why you are using the GPS, and you would define that here. Okay, so I've got my assets in here. I also need to get this WAV file, and so what I'm going to do is, I'm going to drag that right there into the root. I'm going to be presented with this little box, so I'm going to check copy items if needed and make sure my target is the app and hit finish. And that drags in that file. All right. So the first thing I want to do is I need to recreate that button, right? So I'm going to come up here to my library. I'm going to select image, and then I'm going to place an image right there. And then I'm going to go to my attributes inspector, pick an image, and I'm going to choose dark blue BG. All right. But it's not taking up the whole thing. So to deal with that, I'm going to drag it all the way up, like so, and all the way down, like so. But you'll notice that it's not taking up the entire thing, and that's because we need to go to content mode and select aspect fill, and that takes up the whole screen. So the thing with your storyboard in your views is if you look inside here at the bottom, we have all of these different device sizes, right? And if I change to an iPhone 8, the view is going to be a little weird. If I like place an image in the middle, the image is going to be somewhere else. So what I need to define when I'm creating these is constraints. There are a couple ways of creating constraints. I'm going to show you the quick and easiest way, and this is creating automatic or the suggested constraints. So if you click on this little button down here at the bottom, with the little triangle in the bars, you can go add missing constraints, and that will automatically assign these constraints. Okay? And if you click on the item and you come over to the size inspector, you can see that my constraints are here. So I have my leading space, my bottom space, and my top space, okay, to the super view being the frame of the phone itself. And we also have a safe area, which if you click on it here, you can see this is a designated app area that Apple gives you to put the content of your app, okay? You don't want to put content up here because this is where your status bar is, and for the new iPhone 10s or XS, you don't want to put content down there because that's how the user gets home, okay? Again, this is the whole style guide scenario. But for this instance, we're going to do the whole thing because it's not really blocking those. And then what I'm going to do is come over here and I'm going to look for button. And I'm going to drag this right in the middle. And what I want to do now is like come over to my attributes inspector, delete the word button, go to image, and select power button. Okay? But again, I need to set up constraints. I need to say where it needs to sit in the phone. So to do that is I'm going to come to this one here, and I'm going to hit align and choose horizontal center and horizontally in container and vertically in container. That means smack dab in the middle, right? And I'm going to hit add to constraints. All right, I want to see what this looks like on an actual iPhone. So I come up to the top left here, and I click this button, and I have access to my actual devices. My generic device, which you use to deploy to the App Store, and all your simulators. So I'm using the XS Max, so I'm going to choose that as a simulator, and then I'm going to push the play button. It's going to take a little bit. That being said, if you click on the simulator button here and you go to add additional simulators in that dialog, you can actually choose one of your devices that you've connected previously and say connect through the network. And then you can just deploy or run all of your apps to your device wirelessly. So you don't need cables, okay? All right, so this is my simulator. And you'll notice it's a little big, right? So what I want to do now is bring it to the actual phone size. So if I go up to window, I can hit physical size, and that's the physical size of the phone. So I'll know exactly, pixel perfect, what this app's going to look like. Why is this coming up? That's a first. Are you gonna work for me now? All right. So I know what this app looks like now on an actual iPhone, right? The button, I can click it, but it obviously doesn't do anything. All right, so now I'm gonna come back over here, hit stop. And I wanna create another view that I will show and hide later. So I'm gonna go to my library, click view, scroll down to view, and I'm gonna drag that baby over, put it right there. And this is the third way to create constraints. What I want to do now is I want to drag this all the way there, and I want to drag this all the way there. And to manually create constraints, you'll notice there's some margin around this, right? And I want to get rid of that. So what I'm going to do is click this little TIE fighter, is what we call it. It's going to come up with a dialog. And this is where you can add your constraints manually. So what I want to do now is click this drop down and select view and hit 0. And this little icon here lights up. Then I'm going to go to the rest of them. Select view, not the saved area. Hit 0 and 0 and view 0. I don't want the margins. And then I'm going to add constraints. And you'll notice it automatically sizes by itself. Okay? Then what I want to do is add an image. Okay, and I'm going to choose clouds and orange oval, except I can't see the clouds that are supposed to be there. So what I'm going to do is select the view. I'm going to come over to my color, and I can create a custom color, which I have defined in the assets, but I've already decided on that, so I'm going to just pick that there and go back to my clouds. Now, for the clouds, I'm going to drag this down here. Okay, and this here to the edge. And I want to bring this up a little bit more. But you'll notice that's not filling out in the bottom. So what I want to do is come over to my content mode and choose aspect fill, and it fills up. Okay, I'll bring that down a little bit. And then I want to add my rocket. So I'll add another image. And choose rocket and bring it out to the edge. Bring it all the way down. But it's not that big. It's not filling up. Again, aspect fill. It's cutting off a little bit, so I'm going to raise this up. All right, that looks good. And then I want to bring this down to hide behind the clouds because I want it to come outside of the clouds, right? But it's not. It's not actually hiding behind the clouds. To fix that, this is making my system slow. To fix that, all I do is come over to this view, and I just drag that up, and it's behind the clouds. It's just layers, okay? Okay, and then all I need now is labels. Label. Put that there. I've got my attribute inspector. I'm going to turn this on to hustle mode. I'm going to change it to white. I'm going to change the font here to bold. And let's do 30. Hit enter. And then I'm going to center that. Right there. Okay, and then since I've already set the properties on this, I just want to duplicate it and change the word, so Command D. And drag that down. And then let's change the font size to 60. And we'll do this to on. And then center that. I'm not going to deal with constraints on these because it's just going to cause some problems, and I want to sit here and debug and stuff like that, okay? Anyways, let's take a look and see what this looks like on my iPhone XS Max. So run that, and you'll notice the first time it took a little bit, but the second time is much faster because it's already loaded everything up into the simulator, and then we are with our app. But obviously now we need to animate it, right? We need to do something with it. So stop. If I come over here to the right and choose Assistant Editor, it's going to bring up my code, okay? What I need to do now is I need to take all the elements that I put in my storyboard on the view and bring them into my code as outlets. So to do that, I need to take my dark blue, and I'm going to hold Control and drag it to where I want it, okay? So click it, hold Control, and drag it. And I'm going to do dark blue BG. And that will create an outlet to where I can reference in my code later and do something with it. So again, my button, Control, holding Control, drag it. And this is going to be power BTN. Okay. And then I want to take this view controller, but I'm going to name it something different. So I'm going to just click it once with my mouse, and I'm going to name it Cloud Holder. And then Control drag, and we'll do Cloud Holder. And let's see, I need to do something with the rocket. I need to animate it, so I'm going to do that as rocket. And my labels, I want to show them later, so we'll do hustle LBL, and then on LBL. And I've got all my outlets. However, like I was saying, I need to come in and I need to automatically hide the cloud. So what I'm going to do is click on it, go to my attributes inspector, and check hidden. And now it's hidden. I also want to hide my labels. Those are hidden. No. So I can unhide them at a later time because I don't want to show them until after the rocket has gotten to the top. Okay, and that means when I run the app now, only my power button and that dark blue background is going to show. So when I click that power button, it needs to do something, right? And this is where we create an action and not an outlet. So what we do is click it, hold Control, drag it over, and we now are presented with an action if we drag it to the location of under view did load, which is this main function here. If we drag it under that, it'll automatically select action for us. If it doesn't, you can go here and choose outlet, outlet collection, or action. All right, so now this is where I'm going to be very Swifty, right? I need to create a function that tells the reader what it's doing. So power BTN pressed. Now, if I look at that function, well, you know what it does, right? So when the power button is pressed. All right. So when the power button is pressed, what I want to do now is I want to hide the power button, hide the background, and show the cloud holder, right? So to do that, since I've already have my outlets, I'm going to do dark blue dot is hidden equals true, and then power btn dot is hidden equals true, and then I need to show my cloud holder, so cloud holder dot is hidden equals false. Okay? Now let's run it and see what it does. Sorry, the system is a little slow. All right, now if I click the power button, they hide my cloud holder is shown, right? All right, awesome. So now what I want to do is play a sound. So to do that, first I need to import a library called AV Foundation, and it's already there. And then I need to create a global variable called player, so var player, and we're going to give it of the type AV audio player. And I'm going to unwrap it, okay? And then we're going to go into our view did load, and we need to create a path and a URL that we will give the player to use later, so we know what file to play. So first, let path equals bundle.main.path, and we're going to choose the first one, and then I'm going to do a string. And I'm going to say hustle tack on, which is, oops, if I can spell it right, which is this file here. And then as far as the type goes, it's going to be WAV. Okay? And we need to convert that path into a URL. So let URL equals URL. And we're going to do file and choose the first one, and then just pass it path. Okay? That being said, we don't need the storyboard anymore, so I'm going to go up here and click the standard editor and then click on View Controller. This is slowing my system down so bad. And then I don't need any of these other things either, so I'm going to hide them just by clicking these buttons up here, and then I just have my code view, okay? And you'll notice that I have an error here, and it says value of optional type string must be unwrapped. How do we unwrap? At an exclamation point. And then we'll get a warning that says we're not using URL. Well, I'm about to. So we need to do try catch block, so do parentheses, and then in here player equals try AV audio, come on, player, and then we're going to do content of, and then URL, okay? And then player dot prepare to play. Hit enter. You'll notice like a lot of this is just, you know, being written out for me. And then our catch, let error as ns error, and print error dot description. All right, and that'll take care of that. And then to play this, we do player dot play, and then we're gonna run it. Now I push this, sound plays. All right, now all I need to do is animate the rocket and show my labels, right? All right, so stop. Let's do this real quick. I'm just going to write it all out. So UI view dot animate. Come on. And then I'm going to do with duration and animation and completion, and I'm going to do a duration of 2.3 seconds. I'm going to hit tab, enter, backspace, tab, enter, finished. And this fills this all out for me, and hit tab again and backspace, okay? Then all I need to do is self.rocket.frame equals cgrect, which is giving it a position. So when it animates, it's going to change it to that position within 2.3 seconds. And then I'm going to come down to X, Y, width, and height. So the X position is being 0 because it's taking up the whole screen. I want it to go to 20, and my width and height is the width and height of the actual image. So 414 and 691. And then I just need to show the labels, and to do that is self.hustle label.isHidden equals true or false, and then self.on LBL dot is hidden equals false. Command R to run it. And again, if you're choosing your actual phone or iPad, it'll load it on as a new, like it's doing here in the simulator. It'll load it right to your phone, and you can check it right on your phone, okay? Push the button, rocket goes up, hustle mode on, okay? Pretty simple as far as dealing with things. It's all built, for Swift. It's ready to go. Build apps, design them first, obviously. Import your assets, animate them, do what you need to do, right? And you're good to go. You don't have to deal with CSS. You don't have to deal with positioning of anything. You just set your constraints automatically, and it works on all devices, okay? All right. That being said, I'm going to show you now how to deploy an app. So instead of deploying this one, I'm going to come over here and get my Lucky English up. So before deploying an app, you need to go to itunesconnect.apple.com, sign up with your Apple account, your Apple account being the same iCloud account that you use for your computer, and also what you'll be using for when you purchase a developer account if you decide to deploy apps. It's $100 a year. It's actually not that expensive when you consider how much you could make off of the apps themselves, okay? When you do that, then you're going to click on, you'll be presented with this, and you click on apps. And so these are some of the apps that I've worked on in the past, okay? But this is not my personal account, so I'm going to go to my personal account. All right, we are almost done. I'm just going to show you the deployment process and then give you some resources and we can get out of here. And I'll answer any questions. All right, and so you can see the Lucky English. These are my actual personal apps that I built and deployed to the App Store. When you create an app, you first need to click the button, do New App. And remember that bundle identifier that we talked about earlier? You're actually going to create that in your developer account. It's pretty easy. If you want to do it, connect with me and I'll walk you through it. And then you'll choose it here. It will show up here and you pick that. And that's the same bundle identifier that you have to use when you're creating your code, right? That you use inside your app itself. And then you name it, what platform, choose the language, and then the SKU is a reference number that you use internally, and then full access, okay? Once you hit create, you'll be presented with a new app, and then you go into it, and you will have these options. So app information is just generic information. You must fill all this information out or you will be denied. Price and availability is how much you're going to charge, like if you want to charge someone to buy the app, you can do that here, or you can make it free, okay? You can do availability as far as territories, so for which countries, and then distribution for businesses, etc. And then when you first get into this, you're going to be presented with 1.0.0, but I obviously have other versions. And then in here, this is where you're going to fill out all of your app information, what's new, promotional text, keywords, screenshots, which will show up here in a second. So here's a quick tip. You don't need special software for screenshots, okay? Go into Xcode, open or run your app in the biggest simulator, which is going to be XS Max and 8 Plus, okay? XS Max is the 6.5 display, and the 8 Plus is the 5.5 display. And Command S for a screenshot. And just run through your app, take screenshots. Okay? It'll save everything to the desktop and just drag those images right here, and those are your screenshots. Okay? You don't need any special software. You don't need to like take screenshots and make it look like it's on an iPhone and add text. No, screw all that. They want to see what the app looks like. Okay? You do it this way, they're going to be more happy with you. And there are literally people behind the keyboard looking through your app. That being said, you have all of your promotional information. This is where you choose your build that you upload to the store. If you add an icon to the Xcode project, like I showed you before, it'll automatically show here. And then your copyright information, trademark information, and app review information. This is where you need to tell them how to contact you. And if your app requires a sign-in, this is where you give them a demo account. And you have to give them a demo account. Even if it's for a client and it's for like a private internal usage or anything like that, they still have to have a demo account. So they can go in, look at the app, and see how it functions and stuff like that. Okay? They don't care if it's for personal use or not. If you're putting it on their platform, it has to work and function as defined by their style guide. All right, version release information, etc. And then when you have successfully deployed through the app review process, you will then see a green dot and ready for sale. Features is in-app purchases. You have your app promotions here, Game Center, encryption, and promo codes if you have any. And then test flight. So Apple provides you with an app that you can download on your iPhone, iPad, or what have you, that you can use for beta testers. When you upload your app to the App Store, and I'll show you in a second how to do that, you will see it here, okay? You will see it right in this area. And what you will see, though, when you upload it is the app, the build number, and then processing. It takes probably like 20 minutes to an hour to process the app. After that, you'll see a little warning sign here that you need to click and then answer a simple question is, are you using encryption? If you're not, click no, and then it turns into testing and ready to submit. You have access to crashes, screenshots, and then all your testers, and then your App Store Connect users. So App Store Connect users, if you add people to your iTunes account, such as developers, marketers, things like that, they have specific roles, they can have access to these apps. They'll be in here, and they can also test. Or you can create groups and have external beta testers. And you can actually provide them with a link, an anonymous link or a public link that will allow them to sign up anonymously and give you information such as crashes, screenshots, and things like that, okay? So they can use your app. And then, of course, you have test information that you need to fill out before you have access to any of this other stuff, such as marketing, privacy policy, contact information, and why you're testing and what they're supposed to be doing with it. And then you have activity. So activity is all your builds, the current App Store versions that you've deployed and their entire process. And you can see that like I had invalid binary, some issues prior. And then you're also going to see ratings and reviews. And again, I didn't click on this because I wasn't like trying to promote this app, but I actually have a 5-star review on Lucky English by 2 people who really enjoyed my app. So put your apps out there. People will review them, and they will use them, and you might actually get something out of it. And then lastly, you have app analytics, sales, and trends. Okay. So real quick, to deploy an app, did I already close it? Oh, I did, damn it. Okay, sorry. Once you've finally built your app, all you do this setup is really slowing my computer down. Holy crap. Yeah, and it's running pretty hot. Okay, so you come up, make sure all your versioning information and everything's correct, right? You have the right version up, you have the right build, etc. If you try to upload a build that you already have, it's going to deny you. Okay, if you try to submit, like in the area where you are submitting an app to the Apple Store, you have to pick the build. It has to be of the same version. So you need to make sure all your version numbers and everything are the same. Anyways, so once you're done with all of that and you want to upload it to the store, you click generic iOS device, come up to product, and choose archive. Okay, that's all you have to do. You'll see a dialog box after it builds and checks and does all of this stuff. And it usually doesn't take this long. Jesus, come on, baby. Can you cut these out? This just, yeah, make it shorter. Come on, just show the box. Okay. No, because as soon as I say that, it's going to show. All right. Anyway, I'm just going to stop this. You're going to be presented with a box, and you need to select the build version that you have, because it's going to archive it and show you. And then you just hit next and answer all the questions. And it's going to go through the signing process and make sure everything's correct, that you have the bundle identifier in your developer account, and that you have the right build version and stuff like that. And then once it's done and it uploads, you're going to see this box. Okay, upload successful. And then you wait for about 20 minutes to an hour for it to process, answer the encryption question, send it to your beta testers. So that's one thing a lot of people don't do regarding their apps, is they'll just build something and then try to deploy it to the store. Apple does not like this. They want you to go through the whole process of building, testing, getting beta testers, etc., and then submit a version to the store. And if you do so, you're more than likely to get accepted and publish your app. And if you don't, then they'll just deny you. And if you're not following the style guides and you're trying to build a cross-platform app that doesn't look anything like an Apple app, they will deny you. I mean, I've seen them deny you because, the position of some icon or logo wasn't in the correct place, right? Like ridiculous things. You're like, dude, seriously? They're very, very, very strict, okay? But that being said, this stops people from just dumping the market with crap apps like you see on Google Play, right? Okay. Okay, so that's it. That's Swift in a nutshell. That being said, can you send the link for all the resources to the group? All right. Well, actually, we'll send it to this group, okay? We'll send it to the Swift group. So scan this. If you guys want to be a part of the Swift group, if you want to continue learning Swift, I am providing you with a ton of books that I have spent my own money on, probably about $1,000 worth of books. okay, and lots of other videos and other things, okay, that you're getting for free, okay, and also my help. If you guys have any questions or anything like that, then ask me. I'm willing to help. I want to see people use Swift. I want to see the community build, because I'm tired of seeing shitty apps everywhere, right? Like, I want to start to see quality, good apps built right. That being said, I've also provided you with a ton of resources in this PDF. If you want to sign up to the developer account, do so through here. There's tons of articles on how to do things. There's lots of YouTube links and like other websites that you can access. If you go to hackingwithswift.com/100, you can see or have access to a 100-day challenge. I recommend you to go through it. I did it. It literally took me 100 days. I didn't skip around. And it really does help you become a Swift developer, okay? And you guys have access to like tons of resources. Sean Allen, Code with Chris are great YouTubers. Swift by Sundell provides tons of great articles on how to do things. You have lots and lots of resources from the Swift community, including Apple, okay? They give tons of resources. They're constantly wanting people to do things with Swift. So, you know, you put your name out there, like you're bound to be contacted by someone, okay? And that being said, if you can design and you can build Swift apps, like pixel perfect, good quality apps that are accepted, you can make about $100 an hour USD just by being a Swift developer. Bare minimum, like starting, okay? There's people who've been in it for a few years and they're doing $125 an hour as contractors, okay? Easily over $100,000 a year as a Swift developer because of how much demand there is for this. All right. And if you're a Windows user, there's a little link down here. Okay, for you to try and figure that out yourself. And I've been asked about Swift UI. So Swift UI is a new way to build interfaces or UIs that Apple just released in the recent WWDC. I'm not going to get into that because, quite honestly, it's not even out yet, right? Like, you need Catalina, the new operating system for Mac, and you need to have like a beta version of iOS on your phone and like the beta version of Xcode, and like it's complicated to get into that. There's no reason. So if you want to read on it and kind of see how they're moving towards building new interfaces, then you can do so through these links. Basically, Swift UI, like I can build that entire app that we built through code, right? I don't have to use the storyboard. I can write everything through code. And if I were to do that, it would probably be like 50 to 100 lines. But if I use Swift UI, I could probably do it like in 10 to 20 lines. Okay, so there's like big improvements, and they're adding a lot of new stuff with this. And I also recommend watching this YouTube channel, Hacking with Swift Live. They go in and talk about a lot of cool things. There's a lot of good speakers there if you would just want to watch that. And that's it. That's all I got.